Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most powerful and sometimes, let's be honest, frustrating parts of Hibernate. We're going to explore the secret life of your data objects and figure out why sometimes they just don't do what you tell them to. You've been there, haven't you? You're staring at your screen, pulling your hair out. Your code looks absolutely perfect, but the data just refuses to save. Or maybe you get that dreaded lazy initialization exception out of the blue. Well, the problem probably isn't your logic, it's that you don't know the secret state your object is in. And that's exactly what we're going to clear up today. So, here's the game plan. We're going to demystify this whole thing. We'll start by looking at the 4 states an object can live in, then we'll see how it travels between them. We'll even have a little showdown between 2 critical methods, get and load. And finally, we'll map all of this back to the CRUD operations you're using every single day. Okay, let's get right into it. The key thing to realize is that every single entity you work with in Hibernate has its own life story, its own life cycle. And knowing what stage of that life an object is in, that's not just some academic exercise. It is the key to writing solid, efficient, bug-free code. Think of this part like a world map for your data object. There are 4 main territories it can be in: transient, persistent, detached, and removed. Once you understand this map, you can start to control your object's journey. Let's break each one down. First up is the transient state. This is basically the moment of birth for your object. You've just typed new student function. Right now, it's just a plain old Java object hanging out in memory. Hibernate has no clue it exists. It doesn't have a database ID, and any changes you make to it are just gone when the object disappears. To the database, it's a complete ghost. Now this is where the action is. An object becomes persistent as soon as you connect it to a Hibernate session. Now it has a database ID, and more importantly, Hibernate is watching it like a hawk. Any change you make, like setting a new name on it, is automatically spotted by a cool feature called dirty checking. Hibernate sees the change and knows it needs to sync it with the database later. This is the managed state, where all the magic happens. The detached state, well, it's kind of like an object that's moved out of its parents' house. It was persistent, it was managed by a session, but then that session closed. So it still has its identity, that database ID, but it's out on its own now. Hibernate isn't watching it anymore. So if you change any of its data, those changes will not automatically get saved. And finally, we have the removed state. An object here is still technically connected to a session, but you've basically handed it a pink slip by calling session delete. It's on death row, just waiting for the transaction to commit. Once that happens, Hibernate generates the delete statement, and poof, it's gone from the database for good. All right, so we've got our 4 states, but an object doesn't just randomly hop between them. We trigger these moves with specific Hibernate methods. So let's look at the most important journeys an object can take. The most common trip, by far, is going from transient to persistent. You create a new object from scratch, and then you just hand it over to Hibernate by calling session persist. Boom! That's it. In that one line, you've told Hibernate, hey, take this, manage it, save it. And just like that, the object is now persistent. And this brings us to a classic point of confusion: persist versus merge. Getting this right is so important. So here's the dead simple rule. Persist is for brand new, fresh out of the box objects. It's for creating records. Merge is for updating detached objects, things that already exist in the database, but you changed them while the session was closed. Let's really look at that merge action. So, you have a detached student object. You change some of its data. To save those changes, you open a new session and call merge. But, and this is the part that trips up everybody, merge doesn't magically reattach your original object. No, it takes your changes, copies them onto a brand new, persistent object, and then hands that new object back to you. Your original object is still detached. You absolutely have to use the new guy that merge returns if you want to keep working with it. Okay, we've covered saving data. Now let's talk about reading it. You need to pull an object from the database, and Hibernate gives you 2 main ways to do it: get and load. They look almost the same, but the difference between them is massive, and it can have a huge impact on your app's performance. Let's put these 2 head to head. Get is simple and eager. It goes straight to the database right now. If it finds your object, you get it back. If it doesn't, you get no. Easy enough. Load, on the other hand, is lazy. It instantly gives you back a fake proxy object, a placeholder, and only hits the database when you actually try to access its data. But if the object isn't there when it finally looks, it'll throw an exception. So the rule of thumb is this. Use get when you need the data right away or you're not sure it exists. Use load when you are sure it exists and you just need a reference, maybe to link it to another object. It's a great little performance trick. All right, let's bring this all together. We can actually map this entire lifecycle concept directly onto the 4 basic operations that you do all day, every day. Create, read, update, and delete. Let's connect the dots. So first up, C is for create. Every single time you build a new object in your code, it starts its life as transient. The moment you call session.persist, you are actively pushing it across the border into the persistent state. That's what queues up the insert statement. This is the front door into Hibernate's managed world. Next up, R is for read. This is really the act of pulling data out of the database and bringing it into a managed persistent state. It doesn't matter if you use get for an immediate query or load to get a lazy proxy. A successful read always results in a persistent object that your session is now tracking. Okay, and update? This is where the whole lifecycle concept really pays off. If your object is already persistent, you just change it. That's it. You change a property, and Hibernate's automatic dirty checking just sees it and handles the update for you. If your object is detached, you use session.merge to bring those changes back into a new persistent object. 2 different paths, same result. And finally, delete. This is the end of the line. You take a perfectly good, persistent object, you call session.delete, and you flip its state to removed. It's now just waiting for that transaction to commit, which is the signal for Hibernate to issue the final delete statement. See? Create, read, update, delete. It's all just about moving objects between these 4 states. So at the end of the day, this isn't just a bunch of abstract theory, right? Getting a real handle on the difference between transient, persistent, detached, and removed is honestly one of the most practical skills you can have. It helps you stop those really frustrating persistence bugs before they even get written. So, next time you see a weird exception or you're wondering why your updates just aren't saving, you'll know exactly what to look for. You're in on the secret life of your data now. So the only question left is, which bug are you going to go squash with this new knowledge right now?